physics. Then he did a postdoc in Burdeos, France, another postdoc in Albuquerque, in Estados Unidos, doing some kind of chemistry with some bald guy. We don't know that. And then he moved to Argentina, and he's a researcher in Bariloche, in the Balseiro Instituto, where also he is a professor there. So he's going to talk about human stupidity.
Yes.
Thank you very much, Marcelo.
Okay, thanks to the organizer for the invitation to give this talk in the frame of the school. And today I will talk to you about the 5 fundamental laws of human stupidity that were enunciated by Carlo Cipolla, and how we can analyze this law by means of an evolutionary game. But first, let me introduce you Carlo Cipolla. Carlo Chipola was an Italian economic historian who, among his writing, and just as a joke, he wrote a very short book that was called The 5 Fundamental Laws of Human Stupidity. But he didn't know, he didn't thought that his book would have a high diffusion among the academic researchers. Because, despite that it was only a joke, he contained very deep truth. So we will see now which are these basic laws of human stupidity and how we can translate this law into a game and make this game to evolve and see why I am saying that the human stupidity is something that is quite bad for the population. Okay? So, but first, it is important to define what was stupidity for Carlo Cipolla, because stupidity can be understood in several ways. He said that stupid people are seen as something with incredible power, and which they behave without regulations, and they manage to operate in a coordinated way with a lot of success. The idea of stupidity for Cipolla has nothing to do with intelligence, and has more to do with the fact that there are some people that they behave in a way that they make some damage to themselves and to the population, to the other individuals of the population. This is what Cipolla defines as stupidity. Someone who behaves in a way that not only produces some damage for him or herself, but also for the rest of the society. So let's start, but these that are the, Cipolla divides the population into 4 groups, and according to his definition, one of the groups are the intelligent people, and he said that the intelligent people are persons who know what, they know that they are intelligent. The bandits, that they are aware that they are evil. The naive or helpless, the naive, they are painfully imbued with the sense of his own conduct. They are people that are very candid, and they behave in a very candid way. And also, for the last, he left the stupid people, and he said that the stupid people doesn't know that they are stupid. They contribute to give a greater strength and incidence and effectiveness to his devastating action. So stupid people have a devastating action on society, and they are not aware that they are doing that. And the stupid is not inhibited by self-consciousness. So this is something important. He postulated 5 laws. This is the first one, and it is related to underestimation. The first law says that always and inevitably, each of us underestimates the number of stupid individuals in the world. So this is one of the highest problems, to try to quantify the amount of stupid people in the population. The problem is that we don't know how much of them we will find in the population. So the first law is that there are always an underestimation of the amount of stupid people among the population. Any numerical estimate would prove to be an underestimation. The second law is universality, and this is also important. The probability that a certain person is stupid is independent of any other characteristic of the same person. So Chipola was convinced that being stupid was another characteristic as being tall, blonde, a woman or a man. So stupidity was something that does not depend on the education of the person, does not depend on the economic situation of a given person. Stupidity is something that is all around. You can find people that is stupid among students, among professors, among workers. So stupidity is all around. In a pessimistic way, what Cipolla said that humanity was doomed to deal with stupidity. There are no safe places or solutions to avoid stupidity. The only thing we can do is just to accept this and live with the idea that the rest of our existence will need to deal with stupid people all the time. So this is the second law, and the second law is universality. And again, I repeat, the probability that a certain person is stupid is independent of any other characteristic of the same person. The third law was the idea of loss. And this is what defines what is to be stupid. A stupid person is one who causes harm to another person or group without, at the same time, obtaining any benefit for himself or even damaging himself. So this is the true definition of stupidity for Cipolla. It is someone who causes damage, but at the same time doesn't get any benefit for this damage. This is something that, for example, we will see that the evil people or the bandits, they cause some damage to the population, but at the same time, they get some reward for themselves. On the contrary, stupid people just make some damage, but they don't get any reward for themselves. They behave stupidly. Cipolla didn't consider that the stupidity was a matter of intellectual quotient, but rather a lack of relational intelligence. So this is the key. Stupidity is a lack of relational intelligence. He started from the idea that relating to each other, we can obtain benefits for ourselves and for the others, or on the contrary, we can cause harm to ourselves and to the others. And this idea of this transaction is what will define the four groups I was mentioning before. So we will suppose that we are in a sort of interaction, and this interaction is leading to a sort of transaction, and depending on the result of this transaction, I will find these four groups I was mentioned before. And this definition of the four groups is what I will take as a guide to build the evolutionary game, okay? So Cipolla said that there are people who, with their unlikely action, not only cause harm to other people, but also to themselves. These people belong to the super stupid genre. So there are some stupid people, but there are also some super stupid people, and this is the definition that Cipolla gave in his book. So we have, up to now, 3 laws. And as I mentioned you before, taking into account that stupidity will be defined in terms of the transaction between 2 individuals or more individuals, we can define these 4 groups that I mentioned before. The intelligent person is a person whose action benefits both himself or herself and the others. So these are, in this plot here, on this graph here, we have benefits for themselves, losses to themselves, benefits to others, and losses to others. So intelligent people is here. In any transaction, they cause a benefit to the others and a benefit to themselves. The bandit is someone who benefits himself or herself at other expense. So a bandit will be here because he will get some gain, he or her will get a benefit for themselves, but at the same time will cause some losses to the others. So this is the group of bandits. Then we have the group of candid or helpless or naive persons that with their actions, they enrich the others at his or her own expense. So here are the helpless people. They produce a benefit to the others, but at their own cost. So they produce a loss to themselves. And finally, we have the stupid people. The stupid people is someone who, with his or her actions, harm to another person without obtaining any benefit for him or herself, or even damaging himself or herself. So stupid people are here. They produce losses to themselves and losses to the others. And this is the definition of stupidity. Okay? We can see here a sort of a cartoon with the four groups. This is, here we have an intelligent person who is selling his pig to obtain a reward. Here we are saying a helpless people that he is just given his pig because this one is buying or is selling used pigs, something that is very strange. So this guy is buying this for a pig that maybe it is not a pig. This is a stupid person who is just not looking where he is walking, and there is one other person here at the ladder. So he hit himself, and at the same time makes this other guy to fall from the ladder. And this is a bad person who, when this person is trying to sell this pig, he's going to hit him with this hammer, just to rob or to steal this pig from this guy. So here we have the helpless, the intelligent, the bandits, and the stupid. So I mentioned that there were 5 laws. So let's go to the 4th one. Non-stupid people always underestimate the harmful potential of stupid people. So this is the cost. According to Chipola, we continually forget the danger that stupid people can represent. So stupid people are dangerous and unfortunate because reasonable people find it difficult to imagine and understand what a stupid person will do. They are really powerful in just producing this harm. And this is something also important. Generally, the attack of the stupid people take us by surprise, and even when we suffer it, we find it difficult to organize a rational defense because the attack itself lacks of rationality. So the attack of the stupid people lacks any possibility of prevention because we don't know that the stupid people will behave in the way. We cannot, I mean, maybe I am a stupid people too, a stupid person too, but you cannot anticipate the behavior of a stupid person, okay? And we can also fall into the error of thinking that the stupid person can only hurt himself, but this is wrong. We can think that we are immune to the actions of a stupid person, but with thinking in this way, we confuse naivety with stupidity. So naivety is something that will not cause any harm to ourselves, but stupidity, yes. So sometimes we can confuse naivety with stupidity. And believing ourselves invulnerable, we lower our defenses. So if we lower our defenses against stupid people, they just, we are somehow making it easier for them to act in a stupid way. So the 4th law is what we call the cost. Non-stupid people always underestimate the harmful potential of stupid people. The 5th law is the danger. A stupid person is the most dangerous person that exists. The corollary is a stupid person is more dangerous than a bandit. Intelligence and stupidity are not the opposite of one another. So as I mentioned before, intelligence is something that is related to the fact that we interact with another person and we can cause a benefit for ourselves and for the others. Stupidity is not the lack of intelligence according to an intellectual definition of it. It's something different. Stupidity has to do with the effect in a given interaction. No one is intelligent enough to understand their own stupidity, and this is something very important. Okay? So even ourselves cannot evaluate if we are stupid, or sometimes we are behaving stupidly. Okay? So no one is intelligent enough to understand their own stupidity. Okay? This is something that can be read in the Encyclopedia of Stupidity. There is an Encyclopedia of Stupidity. So let's go to the game. in this game, players will interact between them in pairs, and in each interaction, there will be an effect upon themselves and on the mates. Each of the players will get a payoff, as I mentioned to those who are attending the course, the school. The strategies here will be each one of the 4 phenotypes. So the strategy will be to play in an intelligent way, in a bandit way, in a stupid way, or in a helpless way. So these are the 4 strategies of the game. There will be 2 parameters in the game. The parameters are the gains or losses that an individual can cause to him, her, or herself, and Q is the gains or losses that an individual inflicts on the others. So these are the 2 parameters. So according to the laws or to what Chipola wrote, the intelligent behavior or the intelligent strategy will have a value of Py greater than 0 and a value Qy greater or equal to 0. So this is the intelligent strategy. The bandit strategy will have a Pb greater than 0 and a Qb less than 0, because the bandit will gain something, but at the cost of the other person. Stupid people will have Ps less than 0 or less or equal than 0, and Qs less than 0, because not only will cause a harm to the other person, but sometimes he or her will cause, or she will cause a harm to the others, to themselves. And finally, we have the helpless or naive strategy that will have a QH greater or equal to 0 and a pH less or equal to 0. So these are the 4 groups. These are the 4 strategies, and with this, we can build a payoff, taking into account that in each round, a given player will get what the value of P and the value of Q. For example, if an intelligent person is playing with a bandit, he will get Pi and QB, because we'll get the value of the gain that produces to him or herself and the value that the bandit produces to him or herself, okay? So with this, we can build a payoff matrix for the game. And as I mentioned you previously, the payoff will have 2 components, the value of P and the value of Q. So this is the value of the intelligent playing against another intelligent. This is the value of an intelligent playing against a bandit. This is the value of an intelligent playing against a helpless. And this is the payoff of an intelligent playing with a stupid person. Those are the payoff for the bandits playing against the other strategies. Those are the payoff for the helpless playing against other strategies. And those are the payoff for the stupid playing with the other strategies. So one of the things we can do just to try to frame this game within something that is already known is to choose these values in this way. So we can choose PB plus QI greater than PI plus QI and greater than PB plus QB and so on. So if we choose this condition, we will be in a sort of subgame of the prisoner dilemma. So if we choose this condition, the game where only the intelligent and the bandit play will be exactly a prisoner dilemma. So we can see, if we are just fulfilling these conditions, we can see this game as an extension of the prisoner dilemma. So it is important to understand that to fulfill this condition, as QB is less than 0 and QI is greater than 0, it is enough to choose PB greater than PI just to fulfill this condition, okay? So the idea is just to compare this game, that is a game with 4 strategies, to a game like the prisoner dilemma, that is a game with 2 strategies, and see whether we can find something new, and we can use this game to evaluate the effect of the stupid people that is not considered in the prisoner dilemma. So let's go to the usual analysis that we do with a game. And this is something that for the people at the school, I will be showing tomorrow. We will use to analyze the evolution of this game, the replicator equation. So suppose that we have a mean field replicator equation. The mean field replicator equation has this form. So if xk is the fraction of individuals playing a given strategy, for example, the fraction of players playing intelligent or the fraction of players playing bandit, so the evolution of the fraction of this strategy will be governed by this equation. So this equation is telling us that the fraction of a given strategy is proportional of the already present fraction of this given strategy multiplied by the payoff of this strategy minus this is the mean payoff, okay? So if the payoff of a given strategy is greater than the mean payoff, this strategy will, or the fraction of this strategy will grow. But if the payoff of a given strategy is less than the mean payoff, the fraction of this strategy will go down. So as I told you, xi is the fraction of players with a given strategy. And there is something that is important. I will not be showing this. But you can see that in this equation, there is only the value of p, and q is not present. And this is because the q values can be ignored due to a property of the replicator equation. We can subtract all the values of q, and the replicator equation will be the same. So there is no need to consider the value of q, because there is a special property of the replicator equation that tells us that we can only work with the values of p. So as q can be ignored, we will just remove all this value from the payoff matrix, and we will remain only with the values of p. These equations have only one stable equilibrium, and that corresponds to the survival of the bandits. If we work with this mean field equation, the only stable solution is that all the population will tend to behave as a bandit. We start with a given fraction of each strategy, and by the evolution of these strategies, all the population will tend to behave as a bandit.
This is
okay?
Because PB is greater than PI? Or?
Yes. And this is because this is an extension of the prisoner dilemma. So as in the prisoner dilemma, the non-cooperative behavior is the one that is the Nash equilibrium. In this game also, the bandit is the Nash equilibrium. Okay. So the Nash equilibrium of the game is being a bandit. But so there is nothing to do, nothing to say. But suppose that instead of working with this mean field equation, we start to work with a network. And instead of considering that all the individuals can play with each other, that this is what is happening in a mean field equation, we will consider a network with a given property, and we will let a given player just to play with his or her neighbors. So it will not be possible for any individual to play with any other individual, but only within his or her neighborhood, okay? And the networks I will be choosing will be something that are related to what we have seen or Cristina showed in the class, but for the people that were not there, I will start with this sort of networks. I will start with something that is a regular network, and then I will, with a given value of p, that is something related to the randomness, and p goes from 0 to 1, I will start to change some of the links. So with a given probability, I will just go to any of these links, and I will just take this link that corresponds to a regular network, and I will rewire this link randomly. So if p, as p grows, the disorder or the randomness of the network also grows. So we can have, for example, 3 representations of the state of a network for different values of p as p is growing. But in this case, we will do something a little bit different. Instead of only considering one link to rewire at each time, what we will do is just consider 2 links, two pairs of links, and we will interchange those links. Why will we do that? This is what we are doing. So suppose that A and B are linked and C and D are linked. What we do is just, with a given probability, we flip these links, and A will be linked with D, and C will be linked with B. In this way, and contrary to what is happening here, if we start with a degree distribution that is the same for any of the nodes, the distribution will remain the same for all the nodes. So by doing this and only changing one link, the degree distribution changes with the value of P. By doing this, we also get disorder, but the degree distribution is the same. So we have always what is called a regular network. A regular network is a network where all the nodes have the same number of links. Okay? So we will be working with networks with increasing disorder, but always preserving the regularity of the network. And I will show you 3 different dynamics that will tell us how the strategies evolve. We will start with rational limitation. We will also show something about specific imitation. I will just tell you what is each of this one. And we will also consider the probability that occasionally we can behave in a stupid way. So in the third situation, people are not inherently stupid. They are bandits, they are intelligent, or they are helpless, and sometimes they behave stupidly. Okay? And maybe this is something that is more related to what really occurs. I mean, I am sure that any of us at a given moment has behaved in a stupid way. And this is not that we are stupid all the time, but sometimes we do things that can be qualified as stupid. That's stupid. Sorry if I'm somehow offending some of you, but this is true. So I will choose only because just I need to give some values. I will choose these values for P and for Q, though the values of Q do not enter in the mean field equation, but here they will play a role. So the values of Q were not important when I was dealing with the mean field equation, but for this situation, the values of Q are really important. So this is one of the differences between considering players on a network and considering mean field. The values of Q can have some effect on the outcome of the game. And what we will measure is the mean profit of the population. That means we will measure all the payoff of all the game, or all the players, and just to get a mean profit. And we will also measure the ratio of intelligent people to bandit people. So the ratio of the fraction of intelligent to the fraction of bad people. And we will see if the population evolves towards behaving in an intelligent way, or they evolve towards behaving in a bandit way. And the idea is just to analyze the effect of stupid people among the population in making the population to behave in an intelligent way or making the population to behave in a bandit way. And this is what I am calling the destructive effect of stupidity, because so I am somehow telling you the end of the talk, but the effect of stupid people among the population is that the fraction of intelligent to bandit will be lower when the amount of stupid people in the population is higher. And this is the damage that the stupid people is causing on the society. They are driving all the population to behave in a bandit way because of the imitation, because of the example, and because of the evolution of the strategies. So these are, so what is rational limitation? Rational limitation is that after each round, each player imitates the best neighbor. So I play with all my neighbors according to a given strategy. I compare my payoff with the payoff of the other, and I choose the one who has the highest payoff, and I imitate the behavior of this player. Okay? So this is the rational behavior. And here we can see that this is the disorder of the network. Pi d is the disorder of the network, and it's increasing in this way. PS0 is the initial fraction of stupid individuals. And what we see here is that each of these curves correspond to a different value of initially stupid people among the population. And what we see is, remember that this is the fraction of the intelligent to the bad. And depending on the disorder of the network, this is the result we can observe. So this is when there are no stupid among the population, and this is what we see. So here the fraction of intelligent to bad people is not related to the presence of stupid people, but only to the structure of the network. So for a regular and ordered network, the intelligent people will survive, but as we increase the disorder of the network, the intelligent people will be somehow eliminated from the population, and most of the population will try to imitate the bad behavior or the bandit behavior. And apparently there is nothing that we can relate to the existence of stupid individuals here. On the contrary, we see that if we increase the amount of stupid individuals, here is 0 and here is 0.9, the curve is always above the curve of the population, this curve when the initial stupid players is equal to 0. And why is that? And the fact that this is happening is that because there is a sort of screening effect. The stupid individuals are screening the intelligent individuals, and they are not letting them to interact with the bandits. And if the intelligent people cannot see the bandits, they cannot imitate them. So in this case, what is happening is that the stupid are screening the intelligent population, and they do not let the intelligent population to interact with the bad or the bandits, and if there is no interaction, there is no imitation. And this is what is happening here. Okay, so we increase the number of stupid people, and the effect of stupid people apparently goes against what Chipola has been saying. The presence of stupid population protect the intelligent people from the bandit. Okay, so this is something that goes against to what we expected to get with this game. So we move to a different imitation, or a different law for the imitation, and we said the following. The stupid people the intelligent people will imitate the higher global payoff without loss. So what we'll try to do, the intelligent people, is not to imitate the one who has the higher payoff, but we'll try to imitate the one that will cause to the rest of the population the higher payoff. It's a sort of cooperative behavior. So I will try to imitate a given strategy if this strategy will cause a higher payoff to the rest of the population, but without losing anything. So I will not imitate a stupid, or I will not imitate or not a bandit, but I will not imitate, for example, a helpless person, if by imitating this person I can cause a global payoff to the population, but also a loss to me. So the intelligent people will imitate those who produce the higher global payoff without loss. The bandits, and this is a B, not an S, this is a mistake. The bandits will imitate those strategies that produce the higher payoff without taking into account what is happening with the rest of the population. The helpless will imitate those who produce the higher global payoff to the population, and sometimes they will also accept the possibility of having a loss because they are helpless. So the possibility of producing a loss to themselves, but at the same time imitating those who produce the higher global payoff to the population is something that the helpless will imitate. And the stupid, as they don't know they are stupid, they remain stupid. So they don't imitate anyone because they are always stupid. Okay? If we consider this situation, the things start to change. We can look at the white and green curve, remembering that this corresponds to an initial population without stupid persons, and this corresponds to a population with 90% of the population being stupid. And here the situation is different. We can see that instead of what was happening here, that with the disorder of the network, the amount of intelligent people in the population started to decrease, we can see here that the amount of intelligent population started to increase. But this increase is higher when there is no stupid, or when the amount of stupid population is low, and is really low when there is a high amount of stupid population. And you can see there is a sort of transition. You can see that from this, for the amount of stupid or initial stupid population, from 0 to 0.5, all the curves go to the same point. But for 0.9, the curve goes here. So in this case, we can observe a real effect of the stupid population according to what Chipola was telling us. So the problem perhaps was to use an imitation dynamics that was rational. And if we consider imitation dynamic that is more related with the nature of each of the players, the nature of each of the strategies, what we observe finally is that the stupid people has really a destructive effect on the population. And how can we measure the destructive effect? We can measure this destructive effect by considering the mean payoff. This is the mean payoff of the population. We can see that the mean payoff of the population is high when the amount of stupid people, or the initially amount of stupid people was low, and is very low when the amount of stupid people among the population is high. So this is something that tells us how we can measure the damage on the population, because the mean payoff of the population is much lower here than here, okay? And, okay. And this is the third rule, and in this rule, you can remember that what I told you was that the population was divided only in three groups: the good, the intelligent, the bandits, and the helpless. And there was not a fixed population of stupid people. It was only that each of these individuals had a probability of sometimes behave in a stupid way. Okay? So now what we have is the probability of playing stupid. Okay? This is again the disorder of the network. And what we observe here is for different disorders of the network, different curves. And this is what we have here is the probability of behaving in a very stupid way. And this is what we have here is just the fraction of intelligent people among the population. And we observe this is an anomaly that I will not be explaining now because it will be long, but we can see that the population remains intelligent for some values of the fraction or the probability of being stupid, but apparently there is a very, or not a very, but there is a sharp transition for a given value of the probability of behaving stupid that tell us that the population that initially remained mostly as intelligent start to be mostly bandit. So for a low probability of behaving in a stupid way, the population will tend to go to the intelligent strategy. But for a high probability of behaving in a stupid way, the population will tend to go to the bandit strategy. So again, we can see here the effect of behaving stupidly. If the probability is low, so there is no high damage on the society, but if the probability is high, the society will tend to behave in a bandit way, and this is not good, because the mean payoff will go down. So to finish, yes. I will just try to show that this is very close to a transition, and to do that, I will just try to collapse all these curves. And to collapse these curves, what we did was to consider two quantities. one of the quantities was the value at which pi was, or rho y was equal to 0.5. So what was this value here? And also the width of the transition, or this curve. The width, that means what was the width of this, between this point, for example, and this point here. So this is what we measure. This is the, so again, this is the value at which the steady amount of intelligent population was equal to 0.5. So the value of the fraction of stupid individual, of the probability of behaving stupidly, at which the steady value of the fraction of intelligent people was equal to 0.5. And this is the width between the values 0.1 and 0.9 for the fraction of intelligent individuals. So those values were taken from these plots. And then what we do was to draw the curves by using this transformation here. So it's something that is related to the group of normalization technique. And by doing this normalization of the curves, we can observe that all the curves collapse, and they behave in the same way. So this is not a definite demonstration that there is a transition, but tell us that there is a high probability of having a real phase transition between a population being intelligent and a population being bandit. And this transition was mediated by the probability of behaving in a stupid way. So I think that I am on time now, so I will finish with conclusions. So in cases 1 and 2, even the smallest fraction of stupid people produce a notable effect. In the first case, it was going in the contrary way as that was expected. In the second case, it went really in the direction we were expecting. The phenomenon, as I told you, is in the first way was as a result of the screening played by the stupid population, because they isolate the intelligent players from the bandits one. And in the intermittency situation, the results show that there was a crossover between two regimes, and the transition from cooperative regime to the effective one is only sharp for slightly disordered networks and was smoother when the disorder increases. Well, it was possible to collapse the curves, and well, the rest is not very important. And okay, so I will be finishing here. Thank you for being here. And of course, if there are questions.
Thank you. So do we have any question? Yes.
With the intermittency simulations, there is a curve that begins to grow for intelligent people.
Yes.
Sorry. So there is a curve that appears to be raising the number
Yes.
of intelligent people in the population. I didn't understand this effect happening for a high probability of having stupid people, because I thought like you have a lot of stupid people and then that tail
Yes.
over there.
Yes.
Why does this happen?
I can add a comment, question.
Good question. No.
Yes, this is the same that happened to
Yes.
the initial, no? So you have like a border effect or something like that?
No, it's not a border effect. It's an effect of the that has to do with the spatial distribution of the stupid and the bad and intelligent population. This is a sort of mean curve. So there are some curves that behave, that initially start from here, and there are some curves that initially start from here. And this has to do with the fact that as this is a regular network, sometimes there are clusters of bandits, and sometimes there are clusters of intelligent. And depending on the initial conditions, there is an effect of the initial conditions. And this effect of the initial condition is that produces this thing here. So it's only something that is related to the, there are some initial conditions that will give you a population that will go independently of the amount or the probability of behaving like a stupid. You will go to a population where everyone will behave as a bandit. And there are some other initial conditions where the whole population will behave as intelligent. When you just add all these conditions and take the mean value, what you get is this. But this is an effect, maybe it's a border effect. It's an effect of the initial condition that plays an important role when the network is regular, okay? And here you have the same situation. It's something that for a very disordered network and for very ordered networks, there are effects on the initial conditions on the final result.
That makes sense, thank you.
Yes.
Yes.
I have a question also related to the initial condition.
Yes.
So the bandits and the intelligent people, they are in the same proportion in initial
initially,
condition?
they are in the same proportion, but as the network has a given topology, it is important where you locate the bandits and where you locate the intelligent people.
That's why I was going to ask if there is any frequency dependence on the... Because at the end, one of the key mechanisms is that, sorry, so many names. Stupid people are isolating the intelligence to interact with the bandits.
Yes.
So whether there is some sort of frequency dependence on the amount, not minimum number of bandits that you need for that to operate.
We didn't analyze this, but yes, this is something that is interesting. I don't know.
Thank you.
But I mean, the question is, both questions are related. The fact that we have a given fraction of always the same fraction of bandits and intelligent, the final outcome depends on where we locate the bandits. If we locate all the intelligent people together by accident, they will survive. But if we locate all the intelligent individuals just isolated, they will not survive. And this is what we can see here. There are some situations, most of the situations make the population of intelligent people to survive. But there are a few simulations where the bandits invade all the network. And these few situations or these few cases cause this, the fact that this is lower here than here. Okay.
Okay. Any question? I have one.
Okay.
Do you think it's possible to design an experiment, not maybe calling stupid, the bandit, or something like that, but you will define this classification, the categories, in terms of harm to yourself or to the rest of the people? In these terms, do you think it is possible to design an experiment that could be, I don't know, just check with your model?
There is an experiment that is related to the ultimatum game that we will be playing today.
I don't know.
I don't know.
Thought it was a secret.
Maybe we will be playing this game with you today. But there was a generalization of the game where people could burn their own money with the idea of punish the others. So I will burn, for example, $100 in order to destroy $1,000 from another person. Why? Well, we should understand the whole scenario to understand why. But this is something that is related to behaving stupidly, because I cause a harm to myself in order to cause a harm to the others. Okay. And this is something that was done and is real.
Ah, okay.
Yes.
Okay. Thank you. Okay, let's thank Marcelo again.
Okay.
Thank you for coming here. So for the school student, we follow the school in the first floor.